I have been trying to warn for this part, formatting output is very, very useful. With the combination of escape characters and the printf statement, we can line up things very neatly on the screen. And that's something that you'll want to start playing with within your programs. You'll want to be able to make your decimals line up, have tabs so that certain columns line up. And what you can do is by getting a string that lines everything up and leaves spaces for only so many characters, you can then put your variables into that string. And so we call that a format, where the format doesn't care what the actual characters are in. It just wants to know how many spaces to leave behind it. And then the items spill into the format. And so we've been looking at those formatted print statements, and I've been introducing them as I've been programming. And what we have is a %b will take a Boolean value, true or false. %c takes a character, just like a %s takes a string. I feed my single characters into strings. A %d is a decimal integer, and a %s is a floating point number. And a %e will do this in scientific notation. Now, the format statements themselves have extended usage that they can do. So from the format statements, if you let me switch over to the browser here, and let me get you the whole browser on the screen. Sorry, the screen is changing size here, but I want to make sure that we can see the whole browser. So let me make that larger, make that larger. Hey, we're almost there. There's my whole browser. And we'll make this fill the screen. There we go. Over in your additional references, I have a thing called a Printf reference sheet. And so if we open the Printf reference sheet, which I've included where I've gotten it from, Alvin Alexander has done this. And this is very similar in many different languages. Printf comes across. And here are the specifications that we can have. We can have a character, a decimal integer, an exponential floating point in scientific notation, a floating point number, which is a decimal representation. I can have it spit out an integer in base 10. I can have it print out octal numbers. %x, I can have it do hexadecimal. I can have it be unsigned. I can do a string of characters. I can print the % sign, and I can print the % sign with the /%. Java, we're going to want to use %%. And then we can control how wide this is. So a %3 means that the minimum width, it's going to reserve a width for 3 characters. So if I put in a really small number, it will leave a space for the 1. If I put in a large number, the minimum width was 3, so it prints the extra characters. And notice in the formatting, we have the placeholder, which says, hey, I want to leave a place for 3 integer digits. And then this is the argument that falls into the placeholder. We can left justify it. So with the negative sign, that pulls things over to the left. We can use zero fill. So if I want a minimum of 3 digits with zero fill, it will fill in the extra spaces. So the number 1 gets the 2 extra zeros. So you can make something like an odometer on a car. You can do at least 5 wide, and they're putting the quotations here so you can see the extra spacing. Left justified 5 wide pulls it to the left and leaves some spaces over on the right hand side. If you want to see the sign, if it's positive or negative, you can put the plus sign in it. And then with floating points, we can print one position after the decimal point. So 0.1 will give one decimal point. 2 positions, we can make it 8 wide with 2 positions after the decimal point. Notice the decimal point counts in your width. And this is what we can use to start lining up money, because we can have right justified money if we made them all the same width with the same number of decimal places. The decimals would line up. And so we have various formatting that we can do. We can force the strings to be a particular length, right or left justified, so that we leave extra spaces if the string does not fill all the spaces. So %10 is telling me this is going to be 10 wide, and it's going to take a string. And then we have all the special characters. And you've been seeing I've been using newline a lot to do formats. We can do tabs. And so this is a nice little reference. What I want to do here is I'm going to come over to our sandbox. And I'm going to use Printf to line up. Come on, sandbox, come on over. So I'm going to get rid of everything in here. I'm not going to really worry about variables right now. I'll get rid of scanner. Remember, our sandbox is just our play space. So what I want to do is I want to create some decimal numbers. So I'm going to double, and we're going to have, let's say, dinner cost equals $128.47. Double tax is 0.0675%, so 6.75%. Double tip equals 0.25 or 25% tip. And what we can do here is we'll have a space for total cost. So I will do my total. So the double for total is equal to the dinner cost plus tax times dinner cost. Oh, let's make our tip, total tip equal dinner cost times tip rate. Our total tax equals dinner cost times tax. Need a capital C here. And so I have my total tip, my total tax, and my total bill is dinner cost plus total tip plus total tax. Now I've hard-coded everything in, but what I want to do is I want to make a formatted print statement to display this. Now what I'm going to do here is I'm immediately going to do this on multiple lines so I can line things up, because that's what I want to do here. So I'll leave myself some lines for my format statement, and I'll put cost, and I'll do a tab. And then in my cost, let's say we can go up to $1,000. So that's 1, 2, 3, 4, 5, 6, 7 characters wide. So I'm going to do a percent 7.2F, then a new line. And then I'm going to do my next line on my receipt. And I'm going to do tax. And I'm going to do a tab. And %7.2f/n. Notice I'm making the same width on each of these here. I'm hoping to get everything to line up. And then we'll go tip, T. And so I'm tabbing over, hoping to line everything up. And then I want to print out some dashes, right? Like when we want to add everything up. So what I want to do is I want to repeat some characters. And what I can do is I can ask my characters to work to repeat characters. So I'm going to multiply a string, and the string I'm going to do is of a dash. And what this will do here, so the string I'm going to do is I'm going to do %. And this isn't in my Printf reference, but it's a nice technique. Dot $s, and then we'll get the Java clarification. So this is going to multiply a string, and I'm going to need to multiply it so many times. So now I need to fill in my arguments. So the first floating point number is dinner cost. So that's going to fall under the first dinner cost. Then I'm going to have the total tax, the total tip, and I haven't put the total yet because I want to see if I can get that. I want to multiply my character how many times across the screen here. So let's see, 1, 2, 3, 4 plus the tab, 12. So let's say we're going to multiply 20 times, and we'll do this. So right now I want to run this to see what the output looks like. I want to include my total cost once I have this through. So I created a format space to try to line things up, and then I'll come and adjust it. And it does not like the dot in the asterisk, and it doesn't like the star in the asterisk. And then, so yeah, it's putting the number 20 in. So if I come through here, what I want to do is I want to get 20 spaces coming out. So instead of using a C type comment, we'll use a Java printf. Yeah, so Java doesn't natively do C strings. If you've ever heard me come through here, one of the problems I have a lot of the times is that I code in different languages, and I'll use a construct in one language and try to use it in another. This is one of those moments. Let's put the total bill in. And so what I want to do here is I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we'll look at a way of using concatenation in strings to do that. And then I think I'll do a string total, tab, 7.2f/n. Let's get our new lines in here. And that should print everything. So let's try running that now. And oh, it helps if I have a percent sign, right? And notice what we've created. We've created the beginnings of a receipt. I have all my decimal places lined up. I have the cost of the dinner, the tax, and the tip. And we've used the format statement. I've included too many dashes, 1, 2, 3, 4, 5. So if I come back here, I can take 5 of these off. And if I run this again, I've got a nice little receipt. And this is actually the programming style that people use when programming devices that have limited display screens. They will fit things into the screen. And if you're doing point of sale software, and notice if I come through here and let's say I had a much smaller bill. So I only had a $53.28 bill, and I decided to leave a 15% tip. It still lines up, and the spacing is always the same. And so Printf becomes a very powerful tool for making sure our displays are correct. And I think one of the things we'll do in example programs as we come through is we'll make tricks for repeating characters here. Because like I said, C style and Visual Studio style printfs, if I use the star dotted character, I can specify I'm going to repeat it so many times. In Java, I think we're going to have to play with string concatenation to do that for us. And that's something we'll look at in a video or two here. But this is the power of Printf, is we can use these formatting codes to guarantee width on the screen, and it gives us a control of our output. And we start getting much more readable output for our programming, and our programs will meet very specific needs.